Welcome to another Algebra 1 lesson. I'm Mr. Pilarski, and today we're going to be talking about equations with variables on both sides. I work out of the Prentice Hall Algebra 1 textbook, copyright 2009, and this would be lesson 3.3 from that textbook. Our learning objectives for today are: I will be able to solve equations with variables on both sides. I will be able to write equations with variables on both sides for problem situations. Let's take a look at a pretty easy example here. To solve an equation with variables on both sides, use the addition or subtraction property of equality to get the variable on one side of the equal sign. The equal sign is the middle of an equation, When we talk about using the addition or subtraction property to get a variable on one side, that means for this equation, 12x plus 17 is equal to 10x plus 35. We need to get rid of the 10x on the right, or we need to get rid of the 12x on the left. By eliminating it from one side, we get the variable on the other side. So in this case, I'm going to use the subtraction property of equality and subtract 10x from both sides. On the right-hand side, the 10x's are eliminated because they're opposites and leaves 35. Bring down the equal sign, and on the left-hand side I simplify this math, 12x take away 10x, which leaves 2x, and I bring down the plus 17. Now it's a two-step equation that involves multiplication and addition. So to continue to solve this, we need to use the subtraction property again and subtract 17 from both sides. When we subtract 17 from the left side, 17 take away 17 is 0. They're opposites, so they go away, leaving 2x on the left of the equal sign. And on the right of the equal sign, 35 take away 17 is 18. So now it's a one-step equation. So we divide each side by 2. On the left-hand side, 2x divided by 2 leaves us with 1x. Bring down my equal sign, and 18 divided by 2 is 9. Solution to this equation is x is equal to 9. So we can see here we need to use the addition or subtraction property of equality to eliminate the variable on one side. Let's take a look at a problem here. And in this particular problem, I forgot to type the directions in here, but the directions would be to find the value of x. And to find the value of x, it relies upon an idea from geometry, and that idea is vertical angles. Vertical angles are angles formed by two intersecting lines, and the angles that are across from each other are called vertical angles, and vertical angles are congruents. Now that's the symbol for congruent, and in other words, in terms of algebra, if two angles are congruent, that means their measures are equal. So this angle here, 2x plus 12, and this angle here, 5x minus 3, are equal to each other, so that's how we write our equation. We can take this 12x, and we take this 5x minus 3, and we'll put an equal sign in between them. So that's how we develop the equation, based on the fact that vertical angles are equal. Remember, this 2x minus 12 was here, and this 5x minus 3 was here. So that gives us our equation since they're equal. 2x plus 12 is equal to 5x minus 3. And from this point, we need to solve an equation with variables on both sides. So we'll need to use the subtraction property of equality to eliminate either the 2x from the left of the equal sign or the 5x from the right of the equal sign. We can just be consistent with what we did in the first example and get rid of the variable on the right by subtracting 5x from both sides. When we subtract 5x from both sides, 2x take away 5x leaves a negative 3x. Bring down the plus 12 because we haven't done anything with it yet. Bring down the equal sign and bring down the negative 3. So we have the two-step equation, negative 3x plus 12 is equal to negative 3. Next, we subtract 12 from both sides using the subtraction property of equality. 12 and negative 12 are opposites, so they become 0, leaving negative 3x on the left of the equal sign. And on the right of the equal sign, negative 3 take away 12 is negative 15. We finish this up by dividing each side by negative 3, the coefficient of the x. The negative 3's divide out, leaving x on the left of the equal sign, and on the right of the equal sign, negative 15 divided by negative 3 is a positive 5. So the value for x here is positive 5. Remember, all of this we were able to write this equation because vertical angles are congruent, or because vertical angles are equal. Example 2t has two problems for us. The first problem is 3x minus 1 is equal to 5x, or 5 times the quantity x minus 1 minus 2 times the quantity 7 minus 2x. This seems like a pretty scary problem, but it's really not. The first thing we need to do is eliminate the parentheses using the distributive property. So in this case, we'll multiply 5 times x, which will give us 5x, and 5 times minus 1, which gives us minus 5. When we distribute over here, we have to distribute the negative sign with the 2. Minus 2 times 7 gives us minus 14. And then minus 2 times minus 2x, well, that gives a plus or a positive 4x. I haven't done anything with the left side yet, so I just bring it down. On the right-hand side now, we have to gather or add like terms. So 5x and 4x are like terms, and so 5x plus 4x gives 9x. The other set of like terms is minus 5 and minus 14. So negative 5 take away 14 is negative 19. Bring down the equal sign, bring down the 3x minus 1. Now it's like the previous two equations we solved. It has a variable on each side and a constant on each side. So in this case, I think I'm going to subtract 3x from both sides. Get rid of the variable on the left-hand side. 3x minus 3x becomes 0, goes away, leaving the negative 1 on the left. And on the right-hand side, 9x take away 3x is 6x, bring down the negative 19. Since the variable's on the right of the equal sign, I need to get rid of the minus 19. I get rid of that minus 19 by adding 19 to both sides. Negative 1 plus 19, that gives us 18. The minus 19 plus 19 are opposites, so they become 0 and go away, leaving us 18 is equal to 6x. So then we'll divide each side of this equation by 6. (18) divided by 6 is 3, and 6x divided by 6 is x. So we could rewrite this solution as x is equal to 3. So we can see in this problem, we distribute to get rid of the parentheses, added like terms on the right-hand side, use the subtraction property of equality to get rid of the variable on one side, use the addition property of equality to get the variable as the only term on one side, then we use the division property to finally isolate the x by itself. In example B, we have 8y minus 4y minus 6y minus 8 is equal to 2y. Before we do anything, we have to collect like terms on the left-hand side. So we'll do 8y minus 4y, which gives 4y, and then 4y take away 6y gives a negative 2y. Minus 8y, or minus 8, is equal to 2y. Now notice we have a variable on the left and a variable on the right. The variable on the right has no constant term, so I'm going to get rid of this negative 2y by using the addition property of equality and adding 2y to both sides. The negative 2y and the 2y on the left cancel. They become 0, leaving negative 8 is equal to 4y. And then finally, we use the division property of equality to divide both sides by 4. I'm running out of room, so I'm going to continue this up here. Negative 8 divided by 4 is negative 2. And 4y divided by 4 leaves us y. Turning that around, we have our solution y is equal to negative 2. So we can see in both of these examples, it's important to make sure you collect like terms on both sides before you do anything else, before you try to eliminate the variable on either side.